Hello everyone, welcome back to our channel. In today's video, we are going to discuss about rotate array problem. So here the question is given an integer array nums, rotate the array to the right by k steps, where k is a non-negative. So here in this question, we need to rotate the array to the right by k steps. So let's go through the examples. So in the example one, we have the nums array 1, 2, 3, 4, 5, 6, 7 and we have given the k steps. So here k value is the 3. So the expected output is after rotating the array to 3 times, the output is 5, 6, 7, 1, 2, 3, 4. So here we can see clearly in the explanation part, rotate 1 steps to the right means we have rotated 7 to the right. So that's why 7 at the 0th index position 7, 1, 2, 3, 4, 5, 6, and in the rotate 2 steps. So we got 6 at the 0th index, and in the third step we got the 5 also. So 5, 6, 7, 1, 2, 3, 4. So this is the final output. So simple. We need to just rotate the array to the right by k steps. So in the example 2 here, k value is 2 means we need to rotate the array to 2 times. That's why 399 will be the 0th and first index of the array. So here if you see 399, after that -1, -100. These are the examples. Let's understand the approaches to solve this problem. So our first approach is brute force approach. In brute force, we rotate the array 1 step at a time. We take the last element and move it to the front and shift everything to the right. So the array looks like this after first rotation. And in the second rotation, the 6 will move even first and will shift all the elements to right. This is the second rotation. And in the third rotation, we'll shift 5 to the first. So 5, 6, 7, 1, 2, 3, 4. So this approach will work, but it takes O of n into k time. This is the time complexity. So for larger arrays and a big k value, this approach is too slow because every time we need to push the last element to the first and we need to shift all the remaining elements to its right. So for bigger arrays, this approach is not at all feasible. So let's discuss about our second approach. The second approach is reverse using reverse function. Here we are reversing the whole array. So if we reverse the whole array, our nums array looks like this 7, 6, 5, 4, 3, 2, 1. After reversing the whole array, we reverse the first k elements. In this scenario, first k elements means first 3 elements. So if we reverse first 3 elements, 7, 6, 5 becomes 5, 6, 7, and remaining elements are same 4, 3, 2, 1. Now in the third step, we are going to reverse the remaining n minus k elements, means these 4. So 5, 6, 7. If we reverse this part, 1, 2, 3, 4. So we got the output. So this approach will give the result in O of n time and space complexity is O of 1. This is the best solution for bigger arrays also. So let's code for this approach. First, we'll take the vector size in n variable nums dot size. Here we do k equals to k modulo n. If k is bigger than the size of the array, rotation starts repeating. So to avoid that, we are using k equals to k modulo n. So this condition is purely for if k is greater than n. So after that, we need to reverse the nums vector. So first we need to reverse the whole. That's why we are using nums 0 and our last index n minus 1. After that, in the second step, we need to reverse the first k elements. So nums comma 0 k minus 1. So in the third step, we need to reverse the remaining elements. So nums k from k to remaining elements n minus 1. So this is the basic functionality. So now we need to write the function for reverse. So in this function, basically we do the swap only. So void reverse while of start less than end. We need to swap and increment the start, decrement the end. Let's run this code. Typo mistake. Yeah, our solution got accepted. Let's try to submit this one. All test cases got passed. I hope you understood the problem clearly. If you have any doubt, please do let me know in the comment section. Please do like and subscribe to our channel. Thanks for watching.